G'day, my name's Reid, and I'm going to be talking about capacitors and DC circuits. A capacitor is a two-terminal electrical component that stores potential energy in an electric field. Capacitors consist of two conducting materials with a non-conducting dielectrical component positioned in the center. There is a lot of maths, however I'm going to run over some of the basics and show an example of some of the more difficult concepts at the end. The degree of which a capacitor can store energy is given by epsilon area over distance. To calculate the capacitance in a series circuit, the formula is given by 1 over 1 over the first capacitor plus 1 over the second capacitor, and so on. For parallel, it's simply the sum of the capacitors. The energy stored by a capacitor is given by half times the capacitance times by voltage squared, and the charge stored by a capacitor is simply the capacitance times the voltage. As a side note, most of the capacitors will be in the range of microfarads. In a closed circuit, the capacitor gathers charge and the voltage across it changes. The initial rate of voltage change across the capacitor is high, and as the capacitor voltage becomes closer in magnitude to the source voltage E, the rate of change of the capacitor voltage slows down, eventually reaching voltage source E. This is now at steady state. If the energy source is removed, then the capacitor will have a high potential and hence will discharge with the same relationship as charging. This continues until there is no more charge and no more potential across the capacitor. Current flow and voltage charging and discharging phases are in accordance to Ohm's law. Thus, the current flow will decrease exponentially when charging until no current flows, and will increase exponentially until fully discharged. The voltage and current flow across a capacitor can be determined as a function of time by the following formulas. Torr is a mathematical representation of time constants, where at 5 time constants the capacitor will reach steady state, which is when the capacitor is fully charged. At this point, the capacitor will act as an open circuit and all normal calculations in DC circuits can be conducted. This is a quick example of how to calculate voltage and current and energy stored by a capacitor in a circuit. Pause the video at any time to see how it is done.